I want to take you through a few examples of this worksheet so it can help you get started off to a good understanding of exactly what to do on this worksheet. The major focus of this is this is actually going to be kind of what you're going to see on the test. So looking at number 1 right here, it says given an equation you should be able to tell what kind of reaction it is. Okay, that's very simple, so we're going to work through a few of those, and then finally the last part is you're going to be able to predict the products of a reaction when given the reactants again. So section 1, honestly guys, should be super simple. All you have to do is look at this reaction and tell me exactly what happened. So I'm going to do a few of these, and there's no balancing, there's no predicting the products. It's literally telling me exactly what type of reaction it is. Okay, so number 1 should be very simple. You see a compound plus another compound, and it makes 2 new compounds that are different from the reactions. You see that Na is now OH, so that is the outsides, and you see that K is now with PO4, and those are the insides. So that is a double replacement reaction. Okay, that is a double replacement. So, like I said, this should be very simple, that you should just be able to look at this and tell you had 2 compounds and they're both swapping places. Okay, I'm going to skip down to number 3. Now, these are just as easy to recognize, guys. You just have to see exactly what's going on here. This first thing, what is a C and then an H when they're bonded together? What is that called? Hopefully you should know that. Give it a second, think about it. A C and an H. Remember, this is called a hydrocarbon. Okay, and anytime you see a hydrocarbon mixed with oxygen, what is it that you have to have fire with? You have to have oxygen. That gives you boom. Now, the last part that you must recognize are the products. Anytime you have CO2 and water produced, that should tell you that this is combustion. Simple as it gets, guys. Simple as it gets. Can't help you any there. Number 4, you have one single individual atom, and then you have a compound. And what's happening here is that this lead is trying to replace this Fe. And you see it does. The lead is now with the sulfate kicking Fe out by itself. So this is the single replacement reaction. Now remember, one thing you have to do on a single replacement reaction is you have to check the activity series. If the lead is higher than the iron, it will replace. So I do want you to double check and make sure that this reaction is possible and see exactly what happens. Okay, I'm going to do one more and see if you can. I'll tell you what, I'm going to do 2 more just to kind of help you out. You have one single solitary thing. It's nothing added to it. There's no other type of reaction. And look what's happening. It is breaking down into 2 pieces. Now, this is a very specific reaction. And guys, I'm telling you right now, number 5 will be on your test in some way, shape, form, or fashion. Now, it probably will not be calcium, but it will be this type of reaction. Now, to answer the question, this is a decomposition. But what I want you to know further than this, decomposition. Okay, is what type of decomposition this is, because you're going to be required to do this. I promise I'm not going to leave this one off. What this is, and I really want you to recognize this, is that this is a metal carbonate. Again, calcium is a metal and then CO3 is a carbonate. And what it breaks down to is a metal oxide plus carbon dioxide. Guys, I'm telling you now, know this reaction because you will see it. A metal, one more time, let me make sure you get it. A metal carbonate decomposes into a metal oxide plus carbon dioxide. Make sure you know exactly what type of reaction that is. And finally, number 6, you have one atom plus one atom of something else, and you have put them together to make a compound. What is that? Think for just a second. 2 basic things. You're putting 2 things together. That should be a synthesis reaction. Now, I know you're asking how in the world do you get P2O3? You will not be required to know how to do that. That goes into a lot much deeper thought than this class requires. So all I'm going to need you to do is recognize that this is a synthesis reaction. So for the rest of these, see if you can figure these out by yourself. And I'm moving on to the next section. Make sure you finish this, because when you turn it in, I am going to grade it for completion. All right, this one, practicing balancing equation. Guys, I can't help you here. All you need to do is practice this. And let me help you. Let me add one thing to this that will make this even better for you, give it even more practice to you. Not only do I want you to practice balancing equations, what I also want you to do is tell me the type. See if you can look at these and say exactly what type this is. Just like right here. You have a hydrocarbon plus oxygen yielding H2O and carbon dioxide. You should look at that and know that that is combustion. Okay? You should easily look at this and not think anything second but combustion. You have a hydrocarbon plus oxygen yields water and CO2. That is always going to be a combustion. Now, there is a little trick on these combustion ones, and I'm going to help you out on this one. And it's double the first. Double the first. Balance as needed. Balance as needed. And then the final thing, after you have balanced, make sure you can do this to all the terms in the coefficients, because if you can't do it by all of them, you can't do it at all, and that is reduce if you can. Okay? Reduce if you can. Reduce if you can. So let's try to balance this one. The rest of them I'm going to leave for you to do by yourself. Hopefully you should be able to do this without any trouble at all. So again, reading the tips over here, we're going to double the first one. So I'm simply going to put a 2. That's going to give me 12 carbons. So I'm going to come over here and put 12 carbons. That's going to give me 12 hydrogens. So there's already 2, so I need a 6 right here. Now let me count up my oxygens. 6 plus 12 times 2 is 24, so I have 6 plus 24. That will give me a total of 30. And then I already have 2, so what is half of 30? That is 15. So that should be your final answer, because can you reduce these values? No, you can't, because 15 is odd. So your final answer to this, and if you want to write it out here somewhere due to space, here, I'll tell you what, let's go ahead and do it. It was going to be 2, 15, 6, and 12. 2, 15, 6, and 12. That should be what you should have. Now, I'm not going to go through any of the rest of these guys. I can't help you balance. You just need to practice to help you learn how to balance. And again, also on all of these, I want you to label them as well. The more you get this, the more you practice labeling them, the better off you will be as well. So I'm going to go down and I'm going to go to the last set, which is predicting the products. So not only do you have to look at, not only do you have to tell me the type, you also have to predict the products and you have to balance it. I'm going to work 2 of these to get you going, and the rest of them you should be able to do. So looking at number 1, the first thing I'm going to do is, I know that this is one single thing trying to jump into a compound. So I know that this is single replacement. Nothing harder to figure that out. That is one element, silver, trying to jump into copper 2 sulfate. So my thing is, this is a single replacement. So anytime you have single replacement, what you have to use the activity series, guys. You have to check the activity series. And you have to look and see, is silver higher on this list than copper? Guys, I'm not going to finish this one because I want you to be able to figure this out on your own, because you should be able to do it. Now, if it will work, figure it out. If it will not work, I do want to help you out, because I don't want to give this one away. But if it will not work, this is what you would put. If it will work, I want you to be able to move the silver over. Remember, you're going to get a new compound. Silver is going to be with sulfate. Copper is going to be all on its own. But again, you check this to see if this will work. Looking at number 2, you have a compound plus a compound. You should easily recognize this is a double. Now, why is this not a acid base? Because acid base is a type of double. Well, it's obvious. There's no H and there's no OH in either of these two equations. So we have the outsides getting together and we have the insides getting together. Now, remember this. Never, ever, ever carry your subscripts over. Guys, if there's a subscript here, leave it there. Do not carry it over. Okay? And remember how we do the general rule of thumb? First on the left should be first on the right. So let's carry that rule of thumb over. So Na is now going to be with Cl. Well, if you check your charges, okay, Na is a +1, Cl is a -1. Very simple, NaCl. And then you're going to get calcium and iodine. That is an I. We'll clear this up so you can see it. Okay. We have Ca and I. Now, why is Ca going to be written first? Well, Ca is a metal, and all metals are cations, and cations are written first in all formulas. So it's a new compound, so check your charges. Ca2+, I is in group 17, so it's 1-, and so your final formula is CaI2. And the last thing you have to do, is it balanced? No, it is not. But I'm not going to help you balance this. You figure it out on your own. And if you need any help, come and see me or ask any of your friends. Okay, you should be able to balance this without any trouble. All right, last one. And the rest of these you should be able to do all on your own. I don't see any of them that would give you any trouble. Tell you what, let's do number 12 because this one might give you a little bit of trouble. This is a decomposition because you have one compound. Now, this is a specific type of decomposition. If you look in your notes, this is an acid. Okay, this is carbonic acid, and it says some acids will break down into carbon dioxide plus hydrogen gas. Okay, carbon dioxide plus hydrogen gas. That is what some of them will break down into. This right here, this CHCOOH. Alright. What you can really do is you can rewrite this as C2H3O2. And the reason it's written a little bit different, I know that this is acetate. And it is written a little bit different, and normally this is a negative charge. As a matter of fact, you can just omit number 16. Don't even worry about number 16. So you can cross it off. See if there's anything else. Let me clear the screen. Again, the rest of these should be pretty straightforward, guys. This right here, I do want, if you'll look in your notes, this is a decomposition. Now, please look this up. This is a decomposition of a metal oxide. So in your notes, I want you to look up what the decomposition of a metal oxide goes through. Make sure you know exactly what the decomposition of a metal oxide goes through. From this point forward, most of them have been double and single replacement reactions. There should not be any trouble with any of these. You should be okay. Just real quick, while I'm thinking about this one, what type of reaction would this be? Okay, you have an H here. These are both in aqueous solutions. This is an aqueous solutions, and you have OH. So this tells you this is an acid, and this tells you that this is a base because of the OH. One last thing, what is the only base you have to know that does not have an OH in it? Guys, you have to memorize this one. If you don't know it yet, it is NH3. Hopefully you should be able to work through these. You should be able to finish this worksheet if you work hard. I'm going to take it up for a grade. This video is maybe 10 to 15 minutes long, so make sure you get to work and turn this in before you leave. Get as much done as you possibly can, and I'll see y'all tomorrow.